All right, let's get right into it. Today, we're talking about a brand new AI model that's been designed to solve a really critical problem happening deep inside the massive data centers that, let's be honest, run our entire digital world. The real challenge here is keeping the cloud running perfectly smoothly, and believe me, it's a much bigger deal than you probably think.
I mean, that sounds completely impossible, right? But that's pretty much the exact challenge data centers face every single second of every single day. They've got to move our applications, our data, our movies, all these virtual cars from one physical computer to another, without any of us noticing a single glitch. So how on earth do they pull that off?
Well, the answer lies in a little bit of digital magic that we're going to call the invisible server shuffle. It's this secret process that keeps our digital lives online and totally uninterrupted.
So this magic trick, it actually has a name. Live Virtual Migration, or LVM. Just think of a virtual machine as a little software computer living inside a much bigger physical server. LVM is what lets engineers pick up that entire virtual machine and move it to a completely different physical box, while it's still running to do things like maintenance or just to balance out the workload. It's the solution to our impossible highway engine swap problem.
Okay, but this is where the story gets really interesting. What happens when those big physical servers, the ones hosting all these virtual ones, start to get totally overwhelmed? This is the core problem, the big one, that needed a much smarter solution. And you know, the stakes here are incredibly high. When one of these host machines gets overloaded, everything running on it just grinds to a halt. Your favorite app suddenly gets super laggy, a company's essential database slows to a crawl, and in the worst-case scenario, things just break. For a data center, that's a nightmare. Now, this isn't a new problem. People have tried to solve this with machine learning before, using models like K-nearest neighbor and support vector machines. But they always ran into this really frustrating trade-off. Some models were fast, but they weren't very accurate at figuring out what to move and where. And the other, more accurate models, they took way too long to make a decision. There was this big gaping hole that needed something better. And this is what led researchers to a really cool new idea. If one algorithm isn't enough to get the job done, why not assemble a team? And that's exactly what they did. They created this new hybrid AI model that combines the strengths of three totally different approaches to attack this overload problem with, frankly, unheard of precision.
First up on the team, you've got the strategist. This is the Markov Decision Process, or MDP. Its whole job is to take a 30,000-foot view of the entire data center, assess the state of every single server, and figure out the best overall game plan, the best policy for when and what to move. It sees the big picture.
Next, we bring in the optimizer, the genetic algorithm. And this is where it gets really clever. This algorithm literally mimics evolution. It generates tons of possible solutions, and then it uses crossover and mutation to evolve them over generations, constantly weeding out the weak ones until it finds the absolute fittest, most perfect new home for that virtual machine. And finally, you have the decision maker, the random forest algorithm. So after the strategist sets the plan and the optimizer finds the best candidates, random forest steps in to make the final call. It works by building hundreds of tiny, simple decision trees and then basically taking a vote among all of them. It's like the wisdom of the crowd, and it makes its final prediction incredibly accurate and reliable. So you've got this AI dream team assembled. You have the strategist, the optimizer, and the final decision maker. The big question is, how well does it actually perform when you let it loose on a real data center workload? Well, the results are pretty staggering.
This is it. 99%. The hybrid model achieved an accuracy of 99%. In the world of high-stakes data centers where every single percentage point counts, a number like that is an absolute game changer.
And to really put that 99% into perspective, just look at this comparison. This isn't just a little bit better, it's a massive leap forward. The previous models, they topped out around 92%. This new model blows them out of the water. And it did it with faster training times, finally cracking that old speed versus accuracy problem.
So how does this team actually work together in real time? It's a really smooth four-step process. First, the MDP scans the whole system to find any overloaded virtual machines. As soon as it finds one, the genetic algorithm jumps in to find the perfect new server. And finally, the random forest gives the green light, and boom, the live migration happens instantly and seamlessly.
Look, this isn't just some cool academic experiment. A breakthrough like this has some really profound implications for the future of the cloud, and by extension, for every single one of us who depends on it every day.
So what's the bottom line here? What does this all mean for you and me? Well, it means the services we rely on every day, from work email to streaming movies, are going to become way more reliable because costly downtime gets slashed. And for businesses, it means their cloud infrastructure gets faster and more efficient, which saves money and boosts performance. It's all about making our digital world run just a little bit better.
And hey, don't just take my word for it. The researchers themselves summed it up perfectly. They said this model has the very real potential to fundamentally change how data centers operate, making them way more efficient and resilient by finding that perfect balance of resources. And that leaves us with one last fascinating thought. This whole thing proved that by combining the unique strengths of different AIs, by building the right AI team, we can solve these incredibly complex problems. It worked for data centers, but what about supply chains, or financial markets, or even city planning? Where else could the right AI team create a 99% solution?